So for more than 4 decades now, Mercury Systems has held an unsurpassed leadership position in the design and manufacturing of space-qualified components and assemblies for defense primes, government agencies, and commercial customers. In fact, we've delivered more than 20,000 space-qualified devices with no in-flight failures. This all uniquely positions us in the space community as having a broad product portfolio ranging from gallium nitride amplifiers, filters, mixers, ferrites, VCOs, telemetry components, integrated products, and storage devices. So we target military and commercial satellites, that is, low Earth orbit satellites, communication receivers, GPS satellites, as well as the International Space Station. A Mercury product has been on every NASA Mars rover project in the last 20 years. We are so well positioned for any radiation-intense environments, including high-altitude aircraft, airborne weapons, and mission-critical ground computing systems.
Mercury has a strong history in military-grade packaging. The same technologies, such as aluminum hermetically sealed cavities, can also be used for space products. In addition to the high reliability, Mercury has years of developing very compact swap-optimized packages. This is especially critical for space applications where size, weight, and power are primary objectives that must be optimized.
Our drives do not have a processor running C code, thus eliminating a failure point, therefore increasing reliability. We've taken our expertise in NAND controller devices to our space devices. Our custom space drive NAND controller uses our built secure error correction algorithms for fault tolerance. And since we maintain 100% authority over the controller, the product is readily customizable for non-traditional use cases. Additionally, we offer the only storage solution in the Space VPX form factor for interoperability. Our devices are very reliable in radiation environments. In fact, our built secure error correction algorithms counter radiation-induced NAND flash errors, thus enabling long-term data integrity. We do this by correcting byte errors and failing devices while automatically replacing worn NAND blocks. We use SLC NAND flash, which reduces the effects of radiation as compared to the newer commercial-grade NAND technologies, such as 3D TLC or QLC NAND. To ensure reliability, our RF products use rad-hard semiconductor components and are individually tested as required by our customer specifications.
Mercury has significant on-site environmental electrical test as well as manufacturing capabilities. Manufacturing includes automated die attach, bonding, and other technologies, and the testing is also automated and can include advanced environmental testing. Instead of having to go outside for environmental testing, Mercury can do shock, vibe, and other tests on site. This reduces lead time, improves quality, and gives us a higher level control of the hardware. Mercury's facilities are AS9100 certified, which gives us a high level of control and quality for all of our space-qualified products.
Mercury offers 3 key advantages: a blazing fast serial rapid I/O interface at 1 GB per second, while other devices use Ethernet or PCI interfaces, which offer much slower data rates. We offer the highest user capacity as compared to competitive products. That is really double the capacity when compared to a similar sized form factor from a competitive product. And our Space Drive NAND controller, TrustStor VPX storage devices, and all our secure solutions are designed and manufactured in a DMEA accredited facility. This incorporates strict supply chain control, thoroughly vetted employees, and an active cybersecurity infrastructure.
Most of our standard components can be procured at a space quality level. Instead of using COTS parts for lower cost, we have an extensive library of parts and components that are proven on space programs. Using these parts, as well as upscreening and additional electrical and environmental screening, we can take standard designs and deliver them at space qualified levels. One focus area where we're spending a lot of development recently is our space qualified GaN portfolio. Mercury has significant experience delivering ground and airborne GaN devices and now has experience with space qualified GaN amplifiers. This semiconductor material is much higher power for a given size, which allows us to further increase the swap optimization. So instead of a large amplifier that has multiple stages and a large output power combiner, a single GaN amplifier can deliver about the same power levels in a much smaller package. And while GaN is a relatively newer semiconductor material, especially when compared to gas and silicon, Mercury's extensive history with this technology give us the confidence that we can use it in space applications.
This is really an exciting time to be part of the Mercury team, the Mercury family, and with close joint collaboration with our key customers, we are well positioned to develop some impressive products that will propel us into the next generation of space applications.